Yes.
Okay, hardness is of two types, ma. One is temporary hardness and permanent hardness. Yeah, what define temporary hardness? Anyone define this temporary hardness? What is the reason behind this temporary hardness, ma? Yes.
Bicarbonates.
Ah, yes, very good. Temporary hardness is due to the presence of bicarbonates of calcium and magnesium ions is nothing but temporary hardness. Yeah, what is permanent hardness, ma? Temporary
So
hardness.
presence of chlorides and sulfides and
Yes, yes.
nitrates of
Okay.
calcium.
Yes. Presence of chloride, sulfates, and nitrates of calcium and magnesium ions is nothing but permanent hardness. Okay, based on this, we have the problems. Okay, what is temporary hardness? What is permanent hardness? What is total hardness? And we have the expressions of hardness. We have four units for the hardness. One is ppm, parts per million. Okay, degree Clark and degree French. Okay, these are important while we are doing the problems. So, what is a hard salt? This calcium bicarbonate, its molecular weight is 162. Magnesium bicarbonate, its molecular weight is 146. Magnesium chloride is 95, and magnesium sulfate is 120. Calcium chloride is 111. Calcium sulfate is 136. Okay, these are the hard salts and their molecular weights. Hard salts and their molecular weights. Okay, we have units for hardness. Okay, first one is 4 units. We have one is 4 units for hardness. One is ppm, parts per million. Okay, number of parts of calcium carbonate. Okay, always you are going to measure the hardness in terms of calcium carbonate equivalent. Why? What is the reason for this? Why we are going to measure this hardness in calcium carbonate equivalent? Because here the reason behind this is the molecular weight of calcium carbonate is exactly 100. Okay, that is the reason for why we are measuring the hardness in calcium carbonate equivalents. Okay, coming to the ppm. What is ppm? Okay, it is nothing but the number of parts of calcium carbonate equivalent hardness present in 10 to the power of, okay, 1 million parts of water. 1 million is nothing but 1 million is here 10 to the power of 6. 10 to the power of 6 parts of water. Number of parts of calcium carbonate equivalent hardness present in 10 to the power of 6 parts of water is nothing but ppm, parts per million. Next one is milligram per liter. What is milligram per liter? Okay, what is milligram per liter? And degree Clark, we have degree Clark and degree French. There are 4 units for hardness of water. Degree French. What is ppm? ppm already we have defined. Number of parts of calcium carbonate equivalent hardness present in 10 to the power of 1 million is nothing but 10 to the power of 6 parts of water is nothing but parts per million. Here 1 ppm is equals to 1 part of calcium carbonate equivalent hardness causing salt present in 10 to the power of 6. 10 to the power of 6 parts of hard water is nothing but ppm. 10 to the power of 6 parts of hard water is nothing but ppm. Second one is milligram per liter. Milligram per liter is nothing but the amount of calcium carbonate equivalent hardness causing salt present in 1 liter of water. Milligram per liter. Milligram per liter is nothing but number of calcium carbonate equivalent hardness present in 1 liter of water. 1 liter is nothing but 10 to the power of 3 parts of water is nothing but 1 liter of water is nothing but milligram per liter. Okay, 10 to the power of 3 is nothing but 1 liter of water. Okay, here 1 kilogram of water is equal to 1000 into 1000 milligrams. 1000 into 1000 milligrams, that is again 10 to the power of 6. 10 to the power of 6 parts. Okay, 1 kg of water which is equal to 1000 into 1000 milligrams, which is equal to 10 to the power of 6 parts. 10 to the, we are showing the relationship between the milligram and ppm. Okay, here 1 milligram per liter equal to 1 milligram of calcium carbonate equivalent hardness present in 1 liter of water. 1 liter of water is nothing but 10 to the power of 6 milligrams of water. Hence, we have 1 milligram per liter equal to 1 ppm. 1 milligram per liter equal to 1 ppm. Okay, next one, the third unit of hardness is units of hardness is degree clerk. Okay, degree clerk is the third unit for the hardness of water. Here in the English system, the hardness of water is expressed in terms of degree clerk. Degree clerk is, here we are going to show this degree clerk as CL degree. CL degree is the representation of degree clerk. Okay, CL degree. Here number of grains. Number of grains is nothing but number of parts. Number of parts of calcium carbonate equivalent hardness causing salt present in 1 gallon. 1 gallon is nothing but 70,000 parts of water. Okay, calcium carbonate equivalent present in number of parts of calcium carbonate equivalent hardness causing salt present in 70,000 parts. 70,000 parts of water. 70,000 parts of water is nothing but degree clerk. Okay, number of parts of calcium carbonate equivalent hardness present in 70,000 parts of water is nothing but degree clerk. Okay, here 1 degree clerk is equals to 1 degree clerk is equals to 1 part of calcium carbonate equivalent hardness present in 70,000 parts of water. Number of parts of, okay, 1 degree clerk is equals to 1 part of calcium carbonate equivalent hardness present in 70,000 parts of water is nothing but degree clerk. Degree clerk. Okay, it is represented as CL degree. Next, coming to the degree French. Okay, degree clerk is from the English system. It is from the French.
Good
unit,
morning, sir. I'm sorry for
Yeah.
interrupting, but
Yeah.
we finished this part and we did the first problem in this also, sir.
Okay, okay. Just I am rewinding because these
Okay, sir.
many of them are absent. Many of them are not there on the day. Okay, yeah, I am just
Okay.
rewinding this one. Without this, there is no. Okay, without this relationship, there is no use of doing the problems. Okay, this relationship is very very important. Okay, many
Okay,
of
sir.
them are not there. Okay, I am starting the problems now. Last one, this one. Okay, yeah. 1 ppm equal to 1 milligram per liter, which is equal to 0.1 degree French and which is equal to 0.07 degree clerk. This relationship is very very important. Okay, now coming to the problems. Coming to the problems. Yeah. Yeah, I'm sharing this problems. The first problem. Yeah, this is the first one we have done, right? Is it visible, ma? 1 liter of water sample collected from the water source in Telangana, as shown in the following analysis, is given in the data, that is magnesium bicarbonate as 14.6 mg milligrams, and okay, magnesium bicarbonate is given 14.6 milligrams, magnesium sulfate as 12 milligrams, calcium bicarbonate as 16.2, okay, calcium chloride 22.2 milligrams, magnesium chloride as 19.5, and is given organic impurities as 100 milligrams. He is asking to calculate the temporary and permanent hardness in degree French. So what is the answer you got for this? What is temporary hardness? What is the permanent hardness? Already we have done this problem, it seems.
Sir, temporary hardness is 2 and permanent hardness is 4, sir.
What is you got in the degree French? Directly
Degree French, yes, sir. Yes, sir. Degree French.
Yeah. 2 is the temporary hardness. We got 2, and the permanent hardness is 4. Okay. Yeah. Now coming to the second one, you need to this problem. 1 liter of water from an underground reservoir Yeah, note on this problem. This is very, very important. 1 liter of water from an underground reservoir in Tirupati town in Andhra Pradesh shown the following analysis for its contents. That is, magnesium bicarbonate is given as 42 milligrams, calcium bicarbonate 146 milligrams, calcium chloride 71 milligrams, and magnesium sulfate 48 milligrams. He is asking to calculate the temporary, permanent, and total hardness of this sample of 10,000 liters of water. 1 liter of water from an underground reservoir. One liter of water from an underground reservoir in Tirupati town in Andhra Pradesh shown the following analysis for its contents. That is, magnesium bicarbonate is given. Yeah, tell me what is temporary hardness, what is permanent hardness, what is total hardness for the given problem. Is given following data, that is, magnesium bicarbonate is given as magnesium bicarbonate, that is 42 and milligrams mg, and is given calcium bicarbonate 146. Yes, what is the answer you got? Calcium chloride. Okay, tell me what is the molecular weight of magnesium bicarbonate?
146, sir.
Okay, 146, right. Calcium chloride is 71 is given, 71 milligrams, and the magnesium sulfate is 48 milligrams. Okay, he's asking to calculate the temporary, permanent, and total hardness of this sample of water, 10,000 liters of water. Is given the following data: magnesium bicarbonate 42 milligrams, calcium bicarbonate 146, calcium chloride 71, magnesium sulfate 48. Okay, you need to write down like in a tabular form of first serial number. Already have done this problem. Okay, first problem the same like that only. First serial number 1, 2, 3, 4 is given for hot salts. And the second one is yeah, what is temporary hardness? What is temporary, permanent, and total hardness? Okay, we have the formula to calculate the hardness of hardness causing salt in terms of calcium carbonate equivalent, that is amount of hardness causing salt. Amount of hardness in terms of calcium carbonate by molecular weight of hardness causing salt into 100. Okay, amount of hardness causing salt and the first serial number. Next, you need to write okay, hardness causing salt. What is the hardness causing salt is given in the following data, and molecular weight of hardness causing salt. The next column is hardness of hardness causing salts in terms of calcium carbonate equivalent. Okay, serial number 1 is given hardness of hardness causing salt, that is magnesium bicarbonate as, okay, how much? 42 mg. Molecular weight of this is 146. Okay, we have the formula to calculate this is hardness of hardness causing salt is, okay, that is amount of hardness causing salt by molecular weight of hardness causing salt into 100. Okay, here is given hardness causing salt is 42. That is 42 by 146 into 100. How much you got?
The 28.7
Right, 28.7 ppm.
ppm.
Right. Next, calcium bicarbonate. Same. Calcium bicarbonate is given 146 in the given problem. Okay. What is its molecular weight?
It is 162, sir.
Okay. Molecular weight of calcium bicarbonate is 162. Right. 162. Here 146 by. Okay, 146 by 162 into 100.
90.16.
90.12, sir. ppm.
90.12 ppm, right? Okay, like that. Remaining third one, that is calcium chloride is given 71 milligrams. Okay, 71 by what is its molecular weight, ma?
111, sir.
Triple one. Okay, triple one. You will get. Okay.
63.96.
Okay. 63.96 for the 63.96 ppm. What about this magnesium
Sir, for
sulfate?
MgSO4 it is 40, sir. 40 ppm.
40 ppm. Yeah. Now it's asking in the question, calculate the temporary and permanent. What are the temporary hardness causing salts here?
So both the
Carbonate.
bicarbonates are
Yeah, bicarbonates are
Bicarbonate.
temporary. Okay. Okay. By adding this 28.7 and 90.12.
118.82, sir.
Okay. By adding this, you will get 11.8.
8.8.
Yeah, see here, given everything. Okay, temporary hardness. The temporary hardness is due to the bicarbonates, magnesium bicarbonate and calcium bicarbonate. Okay, 28.76 plus 90.12, you will get 118.88 ppm. And the permanent hardness causing salts here is calcium chloride and magnesium sulfate. Okay, we got already calcium chloride we got is 40 ppm and the magnesium sulfate is 63.96. That is total. By adding this, you will get 103.96, right?
Yes, sir.
Okay, 103. By adding this, you will get 103.96. Now it's asking the total hardness. Total hardness is nothing but, okay, permanent total. Yeah. Yes, total hardness is nothing but, okay, formula for total hardness is equals to, okay, temporary hardness plus permanent hardness. Temporary hardness plus permanent hardness. Okay, whatever we got in the temporary hardness, that is how much you got, 118.88 plus, okay, 103.96. By adding this, you will get 222.84 ppm. 222.84 ppm is the total hardness. Okay, 222.84 ppm is the total hardness. Now in the question is given, okay, need to calculate for the 10,000 liters of water. Okay, calculate the temporary, permanent and total hardness of this sample for 10,000 liters of water. Okay, now temporary for 10,000. Okay, whatever we got for the permanent hardness we got is 103.96 into 10,000, you will get, okay, 1039600 ppm. Okay, temporary is 118.88 into 10,000, you will get 1188800 ppm. And for total hardness, by adding this 2, okay, sorry, we got total hardness is 222.84 into 10,000, you will get 22 28400 ppm. Any doubts, ma? Any doubts in this? The question is asking,
No, sir.
okay, calculate the temporary, permanent and total hardness of the sample for 10,000 liters of water. 10,000 liters of water. Okay, we are calculating for the 10,000 liters. We got temporary 8.88, and the permanent we got is 222.84. Sorry, total we got permanent is 103.96. Okay, to this we are adding. Okay, we are multiplying with 10,000. You will get the for 10,000 liters of water. 10,000 liters of water. Tell me any doubts you have. Will we proceed for the next problem? Will we proceed for the next? Yeah. Yes. Done. Shall we go for the next one? No one is responding.
Yes, sir.
Yes, sir.
Yeah. Next one. This is a third problem. A sample of hot water contains the following dissolved salts per liter. Now you need to do this problem because already we have done okay, degree clerk and degree French is asking. A sample of hot water contains the following dissolved salts per liter is given. I am writing the data. Magnesium bicarbonate, that is 14.6 milligrams. Okay. Calcium bicarbonate 16.2 milligrams. Calcium chloride 111 milligrams. Calcium sulfate 1.36 milligrams. Okay, is given silica 40 milligrams. Turbidity is given, turbidity that is 10 milligrams. Now is asking to calculate the temporary, permanent and total hardness of water in ppm, degree clerk and degree French. Okay, it's asking to calculate the total permanent, okay, temporary, permanent and total hardness of water in ppm, degree clerk and degree French. It's given the following data. Magnesium bicarbonate has 14.6 milligrams, calcium bicarbonate has 16.2 milligrams, calcium chloride is 111 milligrams, calcium sulfate is 1.36 milligrams, silica is given as 40 milligrams. Okay, turbidity is 10 milligrams. Now is asking to calculate temporary, permanent and total hardness in ppm, degree clerk and degree French. First, write down the tabular form, serial number. Yes, who is that? Yes, mute yourself. Who is that? Hello. K2, 5K2. Calculate the temporary, permanent and total hardness of water in ppm, degree clerk and degree French. Is giving the following data is given Magnesium bicarbonate has 14.6 milligrams. Calcium bicarbonate has 16.2 milligrams. Calcium chloride 111 milligrams. Calcium sulfate 1.36 milligrams. Silica 40 milligrams. Turbidity is 10 milligrams. This is asking to calculate temporary, permanent, and total hardness of water in ppm, degree Clerk, and degree French. Already we know the relationship between this ppm, degree Clerk, and degree French.
Sir, what is the molecular weight of turbidity, sir?
Here, that is the reason I gave this problem. We are not going to consider this turbidity silica in this, okay, temporary and permanent hardness. It is 0. You should not take this silica and turbidity. Got it? What is temporary hardness here? Temporary hardness is due to the bicarbonates. Okay, permanent hardness is due to the chloride, sulfates, nitrates. Is there any silica and turbidity in that temporary and permanent? It is not
No,
there,
sir.
right? Okay,
No,
that
sir.
is the reason. That is the reason. In order to confuse you, they gave this silica and turbidity. Okay, we will take it as 0. We will not consider this silica and turbidity, okay, in the problem. Silica and turbidity, you have to take it as 0. Will not consider this in the problem. Yeah, what is the temporary hardness you got, ma?
20 ppm, sir.
Right, correct. 20 ppm is the temporary hardness. What is the permanent?
The 101 ppm, sir.
Yeah.
And 1 ppm.
101.
Okay, 101, right. 20 is the temporary. Temporary is 20. Permanent we got is 101 ppm. Okay. By doing this, you will get the total. Total hardness is temporary plus permanent. That is 101 plus 20. 121 ppm. Now tell me, in degree Clerk and degree French, need to do individually, ma.
Degree French, sir.
Yeah.
Temporary hardness.
Temporary hardness in the
Is
degree
2
Clerk.
degree French.
How much, ma? I'm not getting.
2 degree French, sir. 1.4 degree Clerk.
2 degree French, 1.
4 degree Clerk.
Yes, right. Right,
The
ma.
permanent is 10.1 degree French and 7.07 degree Clerk, sir.
Okay.
And total is 12.1 degree French and 8.4 degree Clerk.
Right. Ma, respond, everyone, ma. Only 1 or 2 are responding. What about others? Whether you are doing or not, I don't know. Okay, this is what we got, ma. Okay, temporary hardness is due to the bicarbonates of okay, calcium and magnesium. We got 20 ppm here. Okay, permanent is due to the, it is there here, ma. Problem solution for this problem. Okay, temporary hardness is 20 ppm. Okay, magnesium bicarbonate, calcium bicarbonate, that is 10 plus 10 we got, that is 20 ppm. Permanent hardness, calcium chloride and calcium sulfate. Okay, calcium chloride we got as 100 ppm. Calcium sulfate is 1 ppm, 101 ppm. Okay, by adding these two, temporary and permanent, you will get the total hardness, that is 101 plus 20 equal to 121 ppm. Okay, 121 ppm. Okay, temporary hardness. We need to calculate now in the degree clerk and degree French. Okay, temporary hardness. We got 2 degree French. Permanent is 10.1 degree French. Total 12.1 degree French. Okay, we need to calculate whatever the temporary hardness we got 20 into 0.1. In order to calculate in the degree French, 20 into 0.1, you will get 2 degree French. Permanent is, okay, 101 into 0.1, you will get 10.1 degree French. Total is 121 into 0.1, you will get 12.1 degree French. 12.1 degree French. Now degree clerk, same, whatever you got into 0.07. Okay, 0.07. 20 into 0.07, you will get 1.4 degree clerk. Permanent is 101 into 0.07, which is will give as 7.07 degree clerk, and total is 121 into 0.07, 8.47 degree clerk. This is what he asked in the question, in the problem. Okay, is it clear, ma? Any doubts you have in this problem?
No, sir.
Shall we go for the next one? Okay, if they ask in the degree clerk, degree French, ppm, you need to do all this more. Okay, temporary hardness in degree clerk and degree French, total hardness, permanent in degree clerk and degree French, and total hardness in degree clerk and degree French. Yes, yeah, next problem, no one is responding. Is it clear?
Yes, sir.
Okay, yeah, next problem. Okay, calculate the temporary permanent hardness of water sample which contains 6.8 milligrams of calcium sulfate, 33 milligrams of calcium chloride, 40 milligrams of magnesium chloride, 24 milligrams of magnesium sulfate per liter of water sample. Calculate the temporary permanent hardness of water sample which contains 6.8 milligrams of calcium sulfate, 33 milligrams of calcium chloride, 40 milligrams of magnesium chloride, 24 milligrams of magnesium sulfate per liter of water sample. Is given molar mass of calcium as 40 milligrams, magnesium as 24 grams, yes, from where the voice is coming.
Sir, temporary hardness is 0, sir.
Okay, temporary is 0. Is given calcium sulfate as 6.8 milligrams, calcium chloride is 33 milligrams, magnesium chloride 40 milligrams, and magnesium sulfate as 24 milligrams. Calcium chloride 33, calcium sulfate 6.8 is given molar mass. Calcium as 40, magnesium as 24, sulfur 32, oxygen 16, chlorine 35. Now we have the formula to calculate the hardness of hardness causing salt in terms of calcium carbonate equivalent, that is amount of hardness causing salt in terms of calcium carbonate into molecular weight of hardness causing salt into 100. Amount of hardness causing salt in terms of calcium carbonate equivalent by molecular weight of hardness causing salt into 100. Okay, already you know how we have to do serial number, hardness of hardness causing salt in, okay, molecular weight of hardness causing salt. Yes, who is that? Five 29.7 to 40 to 20. J3.
So the permanent hardness is 96.8 ppm and in degree French it is 0.96.
Okay. Yeah, what about others? Yeah, this is how we are going to do calcium sulfate 6.8 into 136, you will get 5 milligrams. Okay, calcium chloride is 29.72 milligrams. Magnesium chloride is 42.10 milligrams. Magnesium sulfate is 20 milligrams. Okay, he's asking not in degree French or degree clerk, just is asking temporary and permanent hardness. No need to convert in degree clerk or degree French. Okay, directly you need to do. Okay, temporary hardness, he did not give any temporary hardness causing salts. Okay, temporary hardness is due to the presence of bicarbonates. Presence of bicarbonates is the temporary hardness. You need to remember that, okay? Because he didn't give any temporary hardness causing salt, directly you will get it as 0. Temporary and permanent hardness of water sample. Temporary is 0 milligrams. Permanent, whatever is given, no, calcium sulfate, calcium chloride, magnesium sulfate, all these are permanent hardness causing salts. Okay, by adding this, you will get 96.82. Is it correct, ma?
Yes, sir.
Okay. Temporary is 0 milligrams, permanent is 5 plus 29.72 plus 42.10 plus 20, you will get 96.82 milligrams. (96.82 milligrams). You just asked to calculate temporary and permanent hardness. Just asked to calculate temporary and permanent hardness of water sample, which contains 6.8 milligrams of calcium sulfate, 33 milligrams of calcium chloride, 40 milligrams of magnesium chloride, 24 milligrams of magnesium sulfate per liter of water sample. Okay.
Yes, sir.
This is how we are going to calculate the hardness, temporary, permanent, total hardness of water given water sample. Okay, if they ask in degree clerk, degree French, you need to remember the relationship. 1 ppm is close to 1 milligram per liter, which is equal to 0.01. Okay, degree clerk and 0.07 degree. Sorry, 0.07 degree clerk and 0.1 degree French is a relationship we have for all this. Okay, hardness of water. Okay.
Yes, sir.
Yeah, any doubts? Any doubts in these problems?
No, sir.
Okay, just if you know this molecular weights of hard hardness, okay, hardness causing salt, you can do this problem easily, okay, and you need to remember this formula, that is hardness of hardness causing salt equal to, okay, amount of hardness causing salt. They give in the question itself amount of hardness causing salt in terms of calcium carbonate equivalent by molecular weight of hardness causing salt into 100. If you remember this formula, you can do this problem. Amount of hardness causing salt in terms of calcium carbonate equivalent by molecular weight of hardness causing salt into 100 is a formula to calculate the hardness of hardness causing salt in terms of calcium carbonate equivalent. Causing salt in terms of calcium carbonate equivalent. Yeah, any doubts, ma? Any doubts you have? We have one or two more problems we'll discuss. Yeah, now is it audible or not?
Audible, sir.
Okay. These are the problems you need to do, ma. In from complexometric titration, we have 2 more problems. Need to do that. Okay. EDTA method. We have problems from EDTA method. We'll discuss.
So can you once show the fourth question solution?
Yeah. Sure. Okay. This is the fourth question, ma. Calculate the temporary permanent hardness of water sample, which contains 6.8 milligrams of calcium sulfate, 33 milligrams of calcium chloride, 40 milligrams of magnesium chloride, 24 milligrams of magnesium sulfate per liter of water sample. This is the fourth question.
Sir, voice సరిగ్గా రావట్లేదు.
It is not clear. Okay, this is the fourth one. That's all for today, ma. So we'll discuss in the next class.
Thank you, sir, for the fourth
Okay,
question.
welcome.
Thank you, sir.
Okay, sir.
Stop
Thank
sharing.
you.
I have one.
Bye bye.
Bye, sir.
Thank you. All we want is now